Okay, next two sections in chapter 7. 7.4 is working with rational exponents. Rational just means fraction. Sometimes the exponent can be a fraction. Okay, so two basic laws again. It says that b to the power of 1 over n is equal to the nth root of b. And a lot of your calculators will have this button there, and you can just punch it right in and get the answer straight there. So it could be square root, could be cubed root, could be fourth root, fifth root. Works exactly the same way. Okay, so the second law is if you have b to the power of m over n, they're two actual numbers, not just the one. You still take nth root of b, and then when that's done, you take it to the power of m. So just this denominator goes under the root sign, just like it did here. The denominator goes under the root sign. So we'll see what that looks like. So take the first example. If I had 64 to the power of 1 over 3, that's basically a fancy way of saying take the third root or the cubed root of 64. So what number, when multiplied by itself and then by itself again, gives you 64? So it's not the square root, but it's the cubed root, the third root. So if you did 4, if you did that on your calculator, find the button. Usually it's something that looks like this. The x root, you press that and figure out the way to do it. Okay, so basically it's the reverse of saying 4 to the power of 3. 4 to the power of 3 is 64. So these are kind of reverses of each other, reciprocals of each other. Okay, so that's kind of how it works. What if you have a decimal? A decimal is considered a rational exponent as well. So two ways of doing that. So either 32, find your power key on your calculator, 0.2. You'll see that the answer is 2, or you could convert the 0.2 into a fraction. 1 over 5 is the fraction in the lowest terms, and then take the fifth root of 32, and you'll find that that's 2 as well. Okay, this one, it's a negative base to a negative exponent, so that's incorporating what we did yesterday. So to get rid of the negative exponent, you put 1 over the positive exponent. Everything else stays the same. The denominator 3, so it becomes the third root of negative 27. And then we're going to square that number after. So the third root, or the cubed root of 27, is negative 3, because negative 3 times negative 3 times negative 3, 3 times, gives you negative 27. And negative 3 squared, negative 3 times negative 3 is 9. So this whole complicated thing becomes 1 over 9. Okay, a couple of questions to work on to practice those, page 415, 1 to 3, 6 and 7. Okay, next section is 7.5, exploring the properties of exponential functions. And if you've seen on the news, you've seen graphs that look like this. So we'll explain how it works. Okay, so the base function is f at x equals 2 to the power of x. So for any function, you can create a table of values. Negative 2, negative 1, 0, 1, 2 is the best way to do it. And if I simply take 2 to the power of negative 2, that's 1 over 2 squared, which is 1 over 4. 2 to the power of negative 1 is 1/2. 2 to the power of 0 is 1. 2 to the power of 1 is 2. And 2 squared is 4. So I take that, and you'll see that on my black line. I plot those 5 points, and I see f at x, 2 to the power of x, what it looks like. Okay, what about if I had 5 to the power of x instead? So what it's going to show is the increase in the curve would be sharper or steeper. So I just did, instead of doing another table of values, I just quickly did it in the yellow here. So this would be 1 over 25, 1 over 5, 5 to the power of 0 is 1, and then it takes off. 5 to the power of 1 is 5, and then 5 squared would be way off the map at 25. Okay, so you'll just see that the higher the base, the sharper, steeper the increase goes. Okay, and these are both known as exponential growth. Okay, let's take the reverse of that. Let's take 1/2 to the power of x. So again, I did my table of values. I see that 1/2 to the power of negative 2 is 4. 1/2 to the power of negative 1 is 2. 1, 1/2, 1/4. So it's the exact reverse of what we saw in these values. Okay, so when I plot that, you'll see that the curve goes the other way. This is known as exponential decay. And again, the bigger the fraction at the bottom, the steeper the slope will be. Okay, so just quickly take a look at page 424, number 4. and it's just going to ask you to identify the different graphs that we've learned so far. Okay, good luck, and let me know if you have any questions online. Have a good day.